Imagine you're working on a REST API that's experiencing slow response times under high load. The system uses a relational database, and profiling shows the bottleneck is in complex join operations across multiple tables. How would you approach optimizing this API to improve scalability while maintaining data consistency? Walk me through your thought process, including any specific database optimizations, caching strategies, or architectural changes you might consider. Nice job breaking down those database optimizations. Now let's dive into scalability in a real-world scenario. You're designing a microservice that handles user session management for a rapidly growing application. The service must track active sessions, validate permissions, and handle sudden spikes in traffic. During flash sales, how would you architect this service to ensure horizontal scalability while minimizing latency? Consider aspects like state management, data partitioning, and load balancing strategies. Good insights on scaling session management. Now, let's discuss data modeling trade-offs. You're designing a feature that tracks user activity logs, clicks, page views for analytics. Compare storing these logs in a relational database, e.g., PostgreSQL versus a document store, e.g., MongoDB. What are the key trade-offs in terms of write performance, query flexibility, and scalability at high volumes? Which would you choose and why? Imagine you're working on a game where the frame rate drops significantly during intense combat scenes with multiple enemies and particle effects. Walk me through your step-by-step approach to diagnosing and optimizing the performance bottleneck, including specific tools or techniques you'd use to identify the issue and potential optimizations you'd implement.
How would you explain the importance of a game loop to a teammate who has never worked on a game before, and how does it directly impact the player's experience?
In a real-time multiplayer game, you've implemented client-side prediction with a rollback system to handle latency, but players are reporting frequent rubber banding and inconsistent state. What are the hidden trade-offs of using aggressive client-side caching for player inputs and world state? And how would you mitigate the resulting desync issues without sacrificing responsiveness? You implemented a caching system for player inventory data to reduce database calls, but now you're seeing stale data when players trade items in real-time multiplayer. Your cache and validation is clearly failing. How do you debug this, and what specific strategies would you use to ensure consistency between the cache and live game state without tanking performance?
When implementing client-side prediction in a multiplayer game to reduce perceived latency, what are the hidden security risks of trusting client-side state too much, and how would you mitigate them without sacrificing responsiveness?